Today I'm going to do lab number 11, and this is about the ideal gas law constant. We're going to go ahead and start with activity 1. It says to record the current air temperature in the room. So here's my thermometer. I'm going to go ahead and pull it out. Oops. I'm going to record the current air temperature. It's 24 degrees Celsius. I'm going to go ahead and put that back and record it in my observations. The next step is to fill the 50 milliliter tube graduated cylinder with water. I want to make sure the meniscus, the reading is right below the 50 line. A little bit more. There we go, up to 50 milliliters. Now it says to fill the 250 milliliter beaker also with water. Alright, it says attach the dropper to one end of the tubing. So this is the dropper from our bottle here, and I've attached the dropper to one end of the tubing. And it says to put the other end of the tubing down the 50 milliliter graduated cylinder. Now it says this next step is going to cause some of the water to overflow from the beaker, so to have a paper towel or towel ready. So it says to place my thumb over the cylinder and invert it into the graduated. And there we go. It's inverted in, and this side of the tubing is out. And it says to record the current gas volume. So it looks like the volume of gas is about 20 milliliters. I'm going to go ahead and record that in my observations. Now it says to turn on the balance. Here's my balance. It's tiered out at 0. And it says to place a waveout on the balance and tare it. Okay, now it says to weigh 1 gram of the 0.1 gram of the yeast. Well, that's a lot more than 0.1 grams, so I'm going to go ahead and just dump some of that back in. It's hard to guesstimate how much 0.1 grams is. That's a little bit too much too. Need about half of that. There we go. It's at about 0.11. I'm going to pour the yeast in this empty 30 milliliter bottle. I'm going to make sure your hands aren't shaking for this experiment as you're dealing with yeast. There we go. I've got the 0.1 gram of yeast in this little bottle. Now it says to measure 1 milliliter of the hydrogen peroxide in the 10 milliliter graduated cylinder and to record the exact volume. It's a little bit above, so I'm going to pour some of it back as I don't want too much. A little bit below. Sometimes it's like Goldilocks, trying to find the perfect measurement. There we go. I'm going to say that's about 1.1. And now our next step is to prepare the end of the tubing with a dropper top. I'm going to pour the hydrogen peroxide into this bottle, and this is when the reaction is going to start. I'm going to connect it to the dropper. We're going to allow the reaction to proceed forth for 1 minute. At least 1 minute. You can see that's happening over here as there's a lot of gas bubbles bubbling up. And over here, the volume of gas is increasing. As now it's at 30. I'm going to let that proceed on so that we can make sure we've got the fullness of the reaction. looks like the reaction is starting to slow down on this side. In the 30 milliliter bottle, you can see some bubbles and the yeast is becoming thicker. But I think we're probably good to go ahead and record the change in volume. So now the volume reads at about 32. So it was 20 milliliters, the volume of gas, and now it's about 32 milliliters. The next step says calculate the change in volume. So that's a 12 milliliter change in volume. We're going to remove the top of the bottle and we're going to pour the contents down the sink. Good thing my sink is right here in my lab. Okay, we're going to go ahead and wash this out and repeat the activity with the same amount of hydrogen peroxide for one more trial, and then in trials 2 and 3, we're going to do 3 and 4, we're going to do 3 milliliters of hydrogen peroxide, and then in trials 5 and 6, we're going to do 3 milliliters of hydrogen peroxide, and then for trials 7 and 8, we're going to do 4 milliliters of hydrogen peroxide. All of this will be used to gather the data to see what happens when more of the hydrogen peroxide is added. Will it create more oxygen gas or less oxygen gas? Thanks so much for tuning in. Bye-bye.